The planets themselves, we're going to go through and we're going to look at a lot of different ideas. Now, when I took this chart, there was some data that they had. We've sent some probes now to Jupiter, past Jupiter, and we've updated the number of moons. We used to think there were 28. We now know there are up to 63. So the more we look, the more we find. And so this data changes as we observe more.
Is there anything on this chart that we need to know why we might have?
You have to know all of it, but no. I usually give you one thing for each test. This is the one thing that I'll give you for the test, okay? And so, but we're going to explain some of this. Some of the data we're not going to touch, but some of the data I will kind of identify and go back and look at. Let's think. I told you, and remember, there's a dividing line, right? There's a dividing line right here between the inner and outer. We said that the inner planets had a lot of density or were very heavy. So here we have numbers that are 5 or almost 4, whereas here we have numbers in the 1s or below 1. For reference, density, if you have a density of less than 1, it floats in water. If you have a density higher than 1, it will sink. So if we could put Saturn in a big bucket, it would actually float. It's that light, okay? And the only way that can happen is there's no rock that is there, okay? And we'll look at some other things about the number of moons, not a lot, a whole bunch, okay? We'll look at a couple other things as we go. Oh, I told you about fast and slow days, all right? In terms of how long it takes to make a day, 24 hours is us. Mars is 24 and a half. That seems about right. 59 days for it to make one day. It takes 59 days for a single day in Mercury. 243 days for one day on Venus. That's a long time. But look at this, 10 and 16 hours for these really large planets. That means they are spinning very, very fast. Okay? Something here. All right, 59 days for one day, 88 days to go around the sun. For Mercury, its day is almost as long as its year. Look at this. For Venus, 243 days for its day and only 225 days for its year. Its years are shorter than its day. Okay? This is what we think about Venus. We think that during the meteor strikes that hit Venus, that it was at one time spinning in the same direction, but it got hit so violently that it stopped its rotation and then just started it going backwards just ever so slowly. That's why it takes so long for it to have a day. It's going backwards because we think that hit happened. For us, 24 hours and 365 days is what we think about. And then for Mars, it's just about a little over 2 years, a little under 2 years, almost 2 years there. If we talk about Neptune, it takes 165 years for it to go around the sun. So that's a long time. In terms of Neptune, we have not known Neptune has existed. It hasn't gone around the sun yet for the entire time we've known about Neptune. It's only partially gone around the sun. Starting to look at each of the planets, what's important about and what do we know about each of the planets? Some of them we know a lot about, and some of them we know very little about. And it depends upon how long we've known about them and what kind of satellites or probes that we've sent to them. And so Mercury is the planet that is closest to the sun. We don't really see it too often because most of the time it's kind of directly in line with the sun. So the only two times we see the Mercury is either right at the dawn or right at dusk, because that's where the sun is close but under the horizon and Mercury is there and we see the reflection. Anytime the sun rises, Mercury is lost. Its day is relatively long, its year is relatively short. And because it is so close to the sun, its day side is about over 400 degrees. That is enough temperature to melt lead. And its night side is negative 180 degrees. Now remember, on the Earth, wind is created because one side is hot and one side is cold. Well, this is a very large difference, over 600 degrees difference. If there were an atmosphere, there would be so much wind, but there's absolutely no atmosphere, and so it doesn't move that energy around the surface. We do know that it has a magnetic field, so that the inside is still liquid and there's an electrical current running inside that liquid core. And so that's kind of surprising because it's really tiny, but it isn't that surprising because it's so close to the sun, it's heated all the time. Venus, on the other hand, if you take a look at the size of Earth and the size of Venus, it is the closest in size to the Earth. So it has about the same mass. Also, it has about the same gravity. It is really, really the closest thing that we have. But if you take a look at it, it has a lot of clouds. It also has a lot of volcanic activity. The clouds and the atmosphere is made up of very high concentration of carbon dioxide, much more than we have now. But that means the greenhouse effect is really going. The surface is over 400 degrees hot. It is also seen best early morning and in the evening. We have sent probes, the Viking probes, to orbit the Venus, and that was done in the 70s, and we attempted to land. Although as the probes went down, they just kind of stopped working, and so too hot and too corrosive an atmosphere for the probes to get down to the surface. But they did take a lot of readings using instrumentation. Mars, the red planet, rotates about 24 hours for every day, a little over, and almost 2 years for every year it takes to go around the sun. It is half the Earth's size and 11% of the Earth's mass with 38% of the gravity. All right. So, on the moon, when the astronauts walked on the moon, could they take nice steps and just walk around? What did they do when they were on the moon? They kind of hopped, right? The reason is it was about 16% of the gravity of Earth, so they hopped around. If by chance we actually went to Mars, 38% would also be difficult for us to walk around. And so if anybody has seen the movie The Martian, okay, he wouldn't be walking around as easily because the force that you use to walk would push you up and he'd be hopping around a bit. Okay, Mars is relatively smaller than the Earth. It has 2 really tiny moons, and they're kind of on the edge of the definition of a moon. What really a lot of people think happened was they were once asteroids that kind of got trapped because they aren't round, they're more kind of asteroid, kind of lumpy shaped, and they're really, really tiny. But we believe they're trapped asteroids. If you take a look at the moon, the Earth, and Mars, Mars kind of fits right in the middle. Just a little bit larger than the moon, but smaller than the Earth. And so in comparison, there's a lot of talk about trying to go to the moon, and it's a little bit more difficult when we actually get onto the surface. Okay, it is not warm enough to have a liquid core. Okay, and we do not see any tectonic activity or volcanic activity, but there are places on the surface of Mars that have magnetic reversals just like we see on Earth. So at one time, there must have been a liquid core. There must have been a magnetic field in which they could align when it was solidifying from liquid and aligned with the magnetic field, and the magnetic field changed over time. The other things, We know that there is no tectonic or volcanic activity, but Mars has the largest volcano in the world, or in the solar system. It is a volcano that is much taller than Mount Everest and much broader than the United States. So there was volcanic activity before. It has absolutely no atmosphere, but if you take a look at the surface, there's evidence of erosions. There looks like riverbeds and river erosion. And one spectacular type of erosion that happens on Earth is the Grand Canyon. There is a canyon that is created in the same way that is much larger than the Grand Canyon that is on the face of Mars. So it looks like there had been running water, but all the water's gone. All the atmosphere is essentially gone. There's a little tiny bit of atmosphere that has a little bit of carbon dioxide, and there's some wind, but it's very, very thin. Okay? What is this right here? What do you see right there? It looks like ice. It's like a polar ice cap. Now, we have polar ice caps, right? But this is frozen carbon dioxide. It's dry ice that is there, not, we think, water. Although there have been signs that in the midst of that dry ice, there is a fairly significant fraction of water, which that's one thing that is important for space travelers. If we go there, is to bring water. It's really expensive. If we could extract it from someplace, that would be reduce the cost of that mission by quite a lot. All right, and so it does have a polar ice cap, mostly carbon dioxide. Okay, now here it says no atmosphere, but it has a very, very thin atmosphere of carbon dioxide. So in the past, we believe that there was water on the surface of Mars and that there was a magnetic field and that it was liquid because we see the signs of erosion. But because Mars was smaller and with less mass, it cooled off faster than Earth. If it cooled off faster, it solidified the core, the electricity stopped in that liquid metal, and the magnetic field went away. Now, remember I told you about the atmosphere of the Earth? It doesn't really stop, it just gets thinner and thinner and thinner. Well, that is the same for the sun. And so its atmosphere, actually we are orbiting inside the outer edges. What we call that is the solar wind. It's the material that's coming off that hits our magnetic field and creates the aurora borealis, but it goes all the way out to Mars. And so when Mars lost its magnetic field, then all of that material coming from the sun is not blocked anymore, and it could displace or hit off all of those molecules. And we believe that Mars lost all of its atmosphere and all of its water over time because of its loss of its magnetic field. Now, there is a real big push to go to Mars. Do you know, can you guess what one of the motivations it is that we go to Mars? We've also sent lots of rovers up there, little remote control cars up there to try to look around. What are they looking for? That's right, they're looking for aliens. We are looking for Martians. Okay, now, do we expect to find a little green Marvin the Martian out there? Absolutely not. Okay, what people or scientists are looking for is this. Okay, we're looking for a place in the solar system that has liquid water because that's where we believe life began, protected from the rays of the sun. If there is liquid water and temperature enough, then life in a scientific atheistic idea might have evolved. And so what the rovers have been up there doing, and what we want to do with some of the work of the astronauts that might go there, is to look for evidences of life. Now, the most complex life that we would ever expect would be single-cell bacteria. Evidences that they are there, just like the evidences that we find in very, very old rock that there is single-celled life. And so, if by chance a scientist finds a cell of life evidence in Mars, the interpretation is this. They have just proven that God does not have to exist for life, that it can happen on its own. Okay? As a Christian, if you actually find bacteria on Mars, does that mean God does not exist? Not, I don't think that. Okay? Do we know everything that God does? Okay? Is your God only large enough to have to create life once? Some people believe, yeah, he only created life once, us. That's it. Okay? And that's what the Bible says. Well, really? Well, the Bible talks about us and our creative event, but it doesn't talk about everything. And just because it isn't mentioned in the Bible doesn't mean it's also not excluded. And so, what happens if in Mars or maybe even somewhere else, is your God large enough to create another Eden somewhere else and maybe they got it right? Bible doesn't say yes, Bible doesn't say no, Bible doesn't say it can't exist. But how large is your God? If God created life here, okay, we messed up so much that he almost destroyed it completely, right? There was one family that was spared, and we are existing today. Maybe there's all things that could happen. Maybe there were other places or other things. I don't know. But what people believe is if we can find evidences of life on Mars that would conclude that evolutionary processes, the idea of evolution, would be supported. That is one of the things that is on the priority list. Not the only thing. Another item that is very important to people is to have populations not just all condensed on one place, because if by chance a meteor hit the Earth unexpectedly, it could devastate life on this planet. But if we had colonizing people in other places, one devastating event may not wipe out the entire species. And so there's lots of ideas about why to go to Mars.